want to introduce the whole Mountain Drinking Water Project team real quick, and then y'all can go back to your comfortable seats. And then we'll kick this thing off. Yeah, to do introduction so everyone knows you.
Well, we got to do this on live too.
Yes, absolutely.
Oh, yeah.
So
That's why I'm kind of like, come on.
I'm going to go on and start. Madison,
I'm going to set the scene.
Yeah. But Madison, you got light in your face.
I know, I had to move out of
okay.
that.
Ready?
Yeah, let's get this going.
3, 2, 1.
Hello, Martin County residents, Mountain Citizens Facebook page. Hopefully folks will start tuning in here shortly when it comes to the Mountain Drinking Water Project report back. First, before we dive into this presentation and tell you all about this project and what we've learned and next steps, I wanted to take a moment to introduce the Mountain Drinking Water team, the folks that Martin County Concerned Citizens has been working really closely with in terms of supporting this work. So we'll do a quick round of introductions. So start off with me. Hi, my name is Madison Mooney. I work for a nonprofit organization known as Like and Knowledge, and I'm also a board member for Martin County Concerned Citizens. Been doing water-related work here in my hometown and community for over 7 years, and I'm very eager and excited to share this project with the rest of my team here today. Now I'm going to pass it off to our UK folks who are here to support our efforts. Oh, wait, I got it. I'm good.
Hi, my name is Jason Unrein. I'm a professor at UK in the Department of Plant and Soil Sciences and the director of the Kentucky Water Research Institute, and I'm one of the co-leads of the team here for UK.
Hi, my name is Emily Byers, and I'm a postdoctoral scholar with the Kentucky Water Research Institute at the University of Kentucky.
Hi, I'm Anna Hoover, and I'm an associate professor in the Department of Epidemiology and Environmental Health at the University of Kentucky College of Public Health. And with Jason, I'm one of the co-leads of the project.
Good evening. My name is Wendell Ormsby, and I'm a professor of civil engineering at UK, and I've been working down here in Martin County for the last 8 years, mainly working with the utility, trying to look at ways to improve the water distribution system.
Hello, and I'm Nina McCoy. I'm a member of the Martin County Water Board, and I'm also a member of the Martin County Concerned Citizens. And we've been working, actually, as Madison said, for the past 7 years on projects dealing with the water here. And so I'm going to hand it over to Madison for a minute, and she's going to talk about the other people who have worked with us.
Yes, of course, and we'll have a shout out at the end of this presentation, but here on the screen you'll see several different partners that have been working with us. Martin County Concerned Citizens here in the middle, Livelihood Knowledge Exchange Network has been a helping partner with this work, the University of Kentucky, some of the members that you just met moments ago, Headwaters, which is an institution that's over in Letcher County, what we like to call our sister county, who has been a part of this work and project as well, and Appalachian Citizens Law Center, who's been a tremendous partner when it comes to supporting our efforts and work here on this project. Now I'm going to pass it back over to Nina, and she's going to do a quick little history deep dive of why we did this project.
So, for years, Martin County has had the name of the stigma, really, of terrible water. Of us not trusting our water, of us not trusting the system, of us not feeling good about drinking about it. And honestly, for me, that started in 2000. And so, in 2017, when the Third Public Service Commission investigation started, Mary Cromer from Appalachian Citizens Law Center came in to get the citizens' take on this. She wanted to know, what do the citizens think about our water? And since this Public Service Commission investigation was going on, she wanted us to have a say. Well, that's in how to run the water system. But what we were interested in is what's in the water. Can we trust what's in the water? And so Mary actually went as a board member of UK CARES, which stands for the Center for Appalachian Research and Environmental Science. She was able to get help from some of the professors at the University of Kentucky to actually study what's in the water. So we started with a smaller grant, which was in 2018 to 2019, that actually we went to people's homes on a random survey and tested 97 homes. And what we were testing for was many different types of metals to see if anything from the slurry spill might be in there. We did not find that. We also tested for disinfection byproducts, which is what we're going to talk about later, because the disinfection byproducts is something we had been in trouble for since about 2002. So as we tested for those things out of those 97 homes, in 2020 we actually did a presentation of what we found, and we can give out some samples of what we found from that. And the only thing we found high were what we call disinfection byproducts. And so Dr. Unrein was able to actually write a new grant, which was a bigger study that would take us over a 4 to 5 year time period to see about disinfection byproducts in our water. And that is what this is. The Mountain Drinking Water Project is studying disinfection byproducts in our water system, because we did not find in the previous study any of the other problems we thought we might find left over from mining or something like that. So in the Mountain Drinking Water Project, what we're looking for, what are the root causes of disinfection byproducts? How do we compare to other water systems? Possible actions to reduce disinfection byproducts for the water system, and how to reduce exposure in our homes. So for tonight, this is what we'll be talking about. We're starting with the project overview, which is where we are right now. We're going to talk about what are disinfection byproducts. So I've said that word so many times, you're probably wondering what the heck. And how we did it, and what our results show, and how they relate to the rest of Kentucky. And then we're going to talk about steps to reduce disinfection byproducts, and then take any questions that you have. So the next slide. All right, so when we talk about disinfecting water, we use chlorine. So our goal is to have clean, safe drinking water. And you have germs in water. It is natural waterways. So it will have some types of germs, bacteria, algae, different types of things. Well, in order to get rid of that, we have to have the chlorine. And so we chlorinate to get rid of that. We disinfect. So that's what we've done. We've disinfected. But, unfortunately, there can be byproducts of that. So when we say disinfection byproducts, we mean chlorinated compounds, because we're trying to remove all the dirt, all the debris out of the water. But unless you distill the water, you're always going to have something in the water. And so if the chlorine binds to that, it can cause a problem. One of the things we want you to realize is that our community is actually leading the way in this. Because of the stigma and the horrible feelings we've had about the water, the University of Kentucky has decided to help us to see what we have, but what we have discovered is that we have about the same problems that's across the rest of Kentucky and across the nation. Disinfection byproducts are a problem in many places. So the efforts that our community scientists have done have been helping us. Martin County is actually leading the way. We're actually, Dr. Unrein takes this show on the road. He goes all around and tells other people what we have found, and then we're trying to make sure that we can help other places as well as our own. So this information will help the engineers to try to work with this in this community, as well as throughout Eastern Kentucky, as well as throughout the nation. Okay, so the next slide. All right. This is basically understanding about how the water system works. It'll help us all if we understand how we deal with water. Our water system takes water out of the river. That is our ultimate source. Honestly, one of the things that we have in our favor is that we have a reservoir. So we take it out of the river, but we put it in the reservoir, and in a way that is a little bit of a holding pond to help us actually be able to let some of the things settle out of the water. And if we can use more out of the reservoir than the river, we're doing better off. Then it actually has to go into the plant. So everything that we're showing here, so everything that we're showing here is actually occurring inside that plant. Well, the first thing they've got to do is they want to get any dirt and debris that's in there. And they start with a process called coagulation, where they chemically treat it to make the materials clump together. And then they do something called flocculation, which is where they physically manipulate it so that those materials will clump together more. And then they want it to form a sediment. What we want is the clean water off the top. So sedimentation occurs. We have some filters that filter some of the material out, and then at this point, we add disinfection. This is where we add the chlorine. As the chlorine goes in, if there's anything in there, if there's any little bits of matter that are in there, then it can bond to the chlorine. And this produces chemicals called trihalomethanes, which just means it is chlorinated compounds with carbon. And then what we have, it goes through the distribution system. Now, this goes through the whole county. So when we're talking distribution system, we're talking all the way to Meat House, we're talking all the way to 292. The whole county is involved in this. A lot of communities have a smaller system. We actually have a huge system. So we have a lot of distribution. So what we're looking at is, where are the disinfection byproducts forming? Are they forming during the treatment? Sometimes they form in the network itself. And so we're looking at, where are they a problem, when are they a problem, and how can we reduce that? Okay, next one.
So, I'm gonna hop in and talk a little bit about, the project and how this whole process was set up at the beginning. So, the Mountain Drinking Water Project had 3 aims. There was aim 1, which is known as the community engagement and the environmental communications. That is known as the Stakeholder Consultation Core. And the Stakeholder Consultation Core encompassed all of our different partners that we've worked with, like I mentioned at the beginning, Appalachian Citizens Law Center, Like of Knowledge, the University of Kentucky, Headwaters, and they were a cohort that we worked very closely with when it came to preparing any communication and engagement materials. So for example, this presentation that is here today, this presentation had to be approved and went through a process with our Stakeholder Consultation Core to make sure it was ready to go for public conversations in this space today. And so they have been very in charge with communicating the work that needs to be done, helping us recruit, and in terms of helping us with doing interviews and listening sessions with some of our volunteers. But we'll get more into that in just a moment. But aim 1 is kind of like setting the foundation for both Martin County and Letcher County. The second aim is aim 2. This is the community science-based exposure model. This, to me, is the most important part of this project and work, because this encompasses the community scientists, the residents. In Martin County and in Letcher County, we had 20+ volunteers that worked with us here in the Martin County community that took water samples once a month. We had different teams. We had team 1 and team 2. There were some samples that came every second Tuesday of the month and dropped off water samples, and the 4th Tuesday of the month. And honestly, when it comes to this work and everything that we've been able to discover, and you'll hear me say this time and time again, if it wasn't for our community and the residents that volunteered and took the time to sample out of their homes once a month, we wouldn't have this information that we have today. And so the community scientists were the aim 2 of this work. And last but not least, the technical resource for utilities. This is the aim 3 of this project. And what this project is going to work towards when it comes to utilities and the technical sources is the data we've been able to collect from this work, from this water sampling. We're going to be able to take this data and connect with our utilities workers, such as the Alliance Water Resources, connecting with our water board, to share this knowledge and share this information, to share the things that we learn, and think about how can we reduce our exposure, not just in a home level, but for a water system level. And that's some things that we're going to talk a little bit about today as we continue on with this presentation. But that's kind of how the structure was for this project. Next slide, please. So, diving in a little bit about inward on the home. So, when it comes to disinfection byproducts, we can become exposed to DPPs by regular drinking water from a bottle. Some of y'all have bottles of water in the audience right now. Working with cleaning supplies like as bleach. Bleach has that chlorine compound in there that Nina was talking about earlier. Doing dishes or cooking, taking a shower or bathing, washing hands, brushing teeth or face, or swimming in a chlorinated pool. These simple day-to-day things we don't think about, you know, can this have, you know, connecting back to disinfection byproducts. But it does, but there's ways to reduce your exposure. And we're going to talk a little bit about that later today, but just wanted to show you common sources of exposure that can be in your homes. Next slide, please. We want to pass the torch back to Miss Nina.
All right, so actually there are different types of disinfection byproducts. What we received, if y'all remember, every quarter we used to get a warning that said we had trihalomethanes and haloacetic acids in the water every quarter for years. And so when we did the study, trihalomethanes was what we decided to focus on because that was one of the things that was high. So trihalomethanes is what we focused on. They are regulated by the EPA and the maximum contaminant level is 0.08 milligrams per liter based on a locational running annual average. Now this is the thing that's kind of weird to wrap your brain around. But it's not about whether or not you have high levels this month or next month. It is, do you have them consistently over a long period of time? So the way that they adjust for that in the regulations is that the water district tests once every quarter in 2 different homes, 2 different locations in the county. And then they get their results and then they average them with the last 3 quarters that they had. If the average is over 0.08, we're in trouble. Looks like this is not working anymore. If the average is over 0.08, we're in trouble. So keep that in mind. So what we were doing is we were testing every month a home. So then we looked at what it was that month, but what we were really looking at was how did that average out over 4 different times before that. Now, at the same time, Dr. Unrein decided he's going to get ahead of the game for a different type of disinfection byproduct. Haloacetonitriles are at this time not regulated by the EPA. So there is no guideline limit. Now, the World Health Organization has set a guideline, and so we decided, Dr. Unrein decided, let's see what's going on in Martin County. While we're doing this project, let's see what's going on with haloacetonitriles, and we'll actually be ahead of the game for what's going on. All right, and next. All right, now, this is the thing, and if you'll remember what used to be on those little cards, it said that there were potential health effects. Cancer, the most confident we are in a actual harm from it is the link to bladder cancer. And so bladder cancer is one of the things that tends to be something that they worry about and why they regulate them in the first place. Now, birth defects and stillbirths, they're kind of still being studied on that, but that is something else that we're interested in finding out more about. Now, over here, if I can just use your little pointer.
Yes, let me make sure it doesn't have a mouse on it because it's my cat's pointer.
Okay. Press the button.
Yeah, it's not a mouse. We're good.
Okay. So, this is us, right here. So this is urinary bladder cancer rates in Kentucky from 2002 to 2022. And this is us All of these other counties that are darker have a higher rate of bladder cancer. We wanted to put this up here because we have heard it said in days past that Martin County had the highest bladder cancer rate in the state, and this shows that we don't have the highest.
We used to.
Maybe we did, but now, right now. Okay, so anyway, next one.
All right, yes, this is me. So we wanted to include this slide to kind of show you what we showed our community scientists or citizen scientists that we worked with on this project. This is kind of like an example of the report backs that we shared with them, but this is a compilation of all the sampling that has been done and all the sampling that has been done throughout the course of this project. Some volunteers sampled for a year, some volunteers sampled for 2 years. And so all of this information is included on this scatter plot here. So sorry, just want to make sure I don't have a mouse up here. That's a butterfly, smiley face. All right, here we go. So here on this graph, you'll see there's tons of purple dots here. The purple dots represent the monthly measurement. So what that means is each dot represents each month that our community scientists went in and sampled and brought it to me to take to the University of Kentucky to get tested for this project. And the diamonds here are known as the locational running annual average. And the way that Nina was explaining how the water district does their annual average, they test quarterly every 3 months. With this project, we've been able to do more of a deep dive average when it comes to the results of all the samplers that we were able to work with on this project. And on the x-axis down here, these are all of our community scientists that came and supported this work. And on the y-axis, this is the TTHMs. And the magic number that Nina was mentioning earlier, 0.08. That is the number that is within EPA regulations. And so, as you can see, some of these diamonds are a little bit above, but again, that's not because it's like long-term exposure, it's just pockets during the season. And we're going to talk a little bit about the season and how that plays a role with this project in just a moment. But if you have questions, hold until the end, because I'm eager to hear your all's thoughts around particular slides, especially this one. Go ahead, Jason. So this is honestly one of my favorite images that we have in this presentation because it kind of shows you where all of our community scientists work. This is a map of Kentucky here. This blue block represents, it's been a day. It's a little piece of Kentucky, all of it's Kentucky. But this is a little piece of Martin County. Sorry, 4 a.m. did not treat me well. I'm still not kept up with this time change these days. Here in this little square is the Martin County Water District. And all these dots that surround here are all the scientists that were involved with this work. And when it comes to our water system and how unique our water system is and our infrastructure is, it takes such a long time for water to get to homes here because of how our infrastructure was built. For example, this we'll hang out with this little dot here next to the triangle. When you think of this home here, for example, you're thinking, how does water get to this home? You would think, oh, here's the water treatment plant. Maybe the water just kind of cuts up this mountain here, hangs a right, and ends up at that home. Actually, the water travels differently to that home. It starts here at the plant, and it goes down and around, all the way down and around, close to almost where Coldwater is, goes back up towards Big Elk, and then hits that home. So that's a long travel distance for this home, for example, to get water. And so you're thinking, when it comes to this map, what's your point? What's the point to get across? The point that I'm trying to get across is that each home and how they're placed throughout the community and county, water travels to them very differently at different paces at different times. And so this infographic just kind of puts out there of all the scientists that we worked with and also just understanding their TTHM's levels based on location.
Locational running average.
Locational running annual average, yes. All right, next slide. Now here's some more about the seasons.
Okay. So, I remember I was telling you about this first study that we did. In that first study that we did, there were 97 homes one time. We just basically went up, knocked on the door, can we test your water? And they said, yeah. And if they did, we tested their water. So anyway, what we found at that time was that it seemed to be seasonal. When it was past June and all the way up to November, it would be worse. Now remember, we started this in December. We started right after Christmas.
Yep.
And then went to the next Christmas. And so that was one of the things that we noticed, is that those homes, it wasn't so much a matter of where the homes were as it was the season, the time of year. So what could this be related to? Well, there are certain things that we thought it could be. One of the things is you're pulling from the river more, the water level is lower. You have a more concentrated organic matter in there. In the summer and the fall, you're getting more organic matter in there. And then it's harder to actually remove all that organic matter, and then you're chlorinating it. Also, one of the things we found that Dr. Enright actually noticed even in the first one is that bromide levels in the river seem to affect it. And we have heard from other communities that bromide levels in their water is making their disinfection byproducts high. Mountain drinking water, the mountain
Mountain Drinking Water Association.
the mountain water
Yeah, Mountain Water Association.
also
yes.
told us that bromide levels that they get out of the river are also a problem. Even though they don't use the tug, they use the
Leviathan.
But so we have to look at what all is going on. If we can reduce water loss and have to remove less from the river, we can actually possibly improve disinfection byproducts. Using the actual reservoir is better than continuously pulling from the river. Is there anything else that I forgot about that, Madison? Because I don't want to, sometimes
No, this is, no,
I get in too big a hurry.
no, it's okay.
All right, so next one.
Oh, this is a good one. This one's your favorite.
Okay, yes. This is one of the things, this is one of the reasons I really pushed for having a sister study. Not just Martin County and disinfection byproducts. Oh, Martin County's always the worst in everything. Our water's awful. So this one of the reasons I really pushed for having Letcher County in this too. So we have Letcher County, but we also wanted to look and see what's going on with other communities. So we looked up, Dr. Unrein was able to get what was going on in other communities with their disinfection byproducts. And this is what they have turned in for the regulatory data. This is Martin County. Both of our locational running average is down, is below the 0.8. This is Louisa. This is Paintsville. That lake has to be a good thing.
Lake.
No, Paintsville Lake.
Paintsville Lake,
And
yeah.
then, but if you'll notice, Big Sandy tends to run high. And that actually goes through Lawrence County as well as Boyd County, but they are pulling from the river. And then this is Whitesburg, which is our sister that actually did the study with us, and Letcher County as a whole. Okay? And then this is showing you how it has what has happened over the years. So we're starting in 2010. We were above the level every quarter. We were getting our results, and they were telling us our water contained these chemicals that could cause all these different problems. So we were above the level. And then what happened in 2017 is the Division of Water finally, I don't know, knocked on somebody's head and said, don't put the chlorine in before you get rid of the materials that are in it. So they changed the chlorination point, which Madison's going to show you this in just a few minutes. When they changed the chlorination point, they had a lot less disinfection byproducts. We have actually not been out of compliance. Now, there are levels that there are times when it's above. And again, like ours, there are times when it's below. But the locational average, running average, whatever it
It's
is.
vocational annual.
There it is.
Yeah, there we go.
The running annual
Average.
average,
Boom.
it has been below. Okay, so that is one thing that we have done, over the past few years. That we're hoping that we can do more to make sure that we have less. We don't want to just meet the guidelines. That's the whole point of this type of study. We want to be better than any
We
other
want to set the
study.
standard.
So we're going to try to set the standard.
That's
Yes.
right.
Okay, so next one. All right. So this is showing you the counties throughout the whole state. This is us. This is Letcher County. Now, I want you to notice some of these places around Lexington, how come nobody's saying, hey, nasty water up here in Madison County? What's going on? We're not hearing any of that. We're here in Martin County. We're here in Martin County, nasty water. Look here, it is all over the place. You gotta understand that chlorinating water is something we have to do because we don't want to die of these horrible diseases. But at the same time, this is a problem throughout the state and throughout the country, actually. So we wanted to make sure that you all understand that we are not the worst. We've got to get rid, until Martin County gets rid of the stigma that we actually bring upon ourselves sometimes by talking about how bad the water is. Other places have problems with their water too. We want the best water, and we want everything we can do to have the best water. But we've got to stop making ourselves look like we're the worst. We're doing it to ourselves. So we want to make sure that you understand that we're in this with everybody else. Okay, I think it's your turn. No, I guess it's still mine. Okay, you're good. Good news. For the haloacetonitrile, that other type of disinfection byproducts that is not actually regulated at this time, and what evidently is the problem that can lead to this: nitrogen, as well as bromide, as well as other organic matter. And then it goes into the treatment plant, and then it causes this problem. They typically occur at lesser concentrations in our community. So I don't know if that's everywhere or if it's just in our community. We do not have I guess, nitrates that we add to soil. We're not the farming community that some places might have a problem with this. Next one. So the good news is, here's the range for the United States of one type, dibromoacetonitrile. Here's where we are. Here's Martin County, there's Letcher County, and Whitesburg. This is the other type, dichloroacetonitrile. This is the range throughout the United States. Here's Martin County, here's Letcher County, here's Whitesburg. So the good news is, that is not something that we obviously have a problem with at this time.
But
Until
we are
we become
getting
that farming community that we all hope to be, I guess. Okay, next one.
And on this slide here, we just wanted to share a little bit with you about our sister county, Letcher County, and how they were a part of this project and work. And as you can see here on this slide, disinfection byproducts concentrations were very similar between Martin County and Letcher County. Martin County tended to have a higher concentration of bromine, which Nina explained earlier just moments ago. And as you can see with this infographic here, you can see this line that represents the bromine to disinfection byproducts. And here's Letcher County's infographic of how it's more of a steady slope compared to Martin County's. But also, again, here's both images of Martin County and Letcher County. And this is just a scatter plot of all the community scientists that were participating in Letcher County with this work. Next slide. All right, so One of the things that I wanted to talk about earlier in the presentation, I was talking about different forms of exposure that you can have in your home when it comes to disinfection byproducts. Well, here, this slide is talking about by ensuring proper home ventilation and using water filters, you can reduce your exposure to disinfection byproducts. For example, in your home, if you've got a stove and you're cooking, you're boiling water, pasta, turn on that little vent that you have. And if you don't have a vent over your stove, crack open a little window just to kind of get some airflow, because disinfection byproducts are also airborne. Same as you're showering. Some bathrooms, my house has one, I have a little vent that I can switch on as I'm taking a nice hot shower, turn on that vent, less exposure of disinfection byproducts. Or cracking open a window. Honestly, during the wintertime, it'd be hard to crack open a window, but if you can bear the cold during the winter, that would be a great way to reduce your exposure. Another thing that I wanted to mention is here on this infographic that says water filter, there's certain types of water filters that are out there in this world that really concentrate of removing disinfection byproducts. Both of these logos here, I'm going to have to pull out my handy dandy notes for this one. The National Sanitation Foundation, this logo here, and then this logo, which is known as the Water Quality Association certification stamp. Both of these logos, if you're on the hunt looking for a water filter, and if you're interested in what types of water filters that are out there, please come see me. I would love to talk more about that.
But it does need to say
But it does need to say
that it removes disinfection.
I was getting to that point, sorry. Sorry, you was getting ahead of me. But the filter has to have these emblems or say it can remove disinfection byproducts. And if you're interested and want to learn more, please come visit here at the Martin County Senior Citizen Center. And lastly, bottled water. Bottled water may not reduce your exposures since some bottled water comes from tap water. And after this presentation wraps up, we have some handouts over here in the corner, and we'll have some extras here at the office here. If residents want to come and get these tips and tricks when it comes to reducing exposure in your home, you're more than welcome to come and get a copy of that information as well. Next slide, please. All right, now we're thinking about the infrastructure. Now we're thinking about the water system itself here in our community. So one of the things that Nina was touching base on earlier is how in 2017, there was a chlorination change with our system. So in 2017, they used to put chlorination at the coagulation stage of the system as it treats it. And by the time it gets to the end to the filtration, the chlorination is gone because it's filtered through. So in 2017,
You've made disinfection byproducts.
you made disinfection byproducts, yes. But in 2017, they changed the chlorination towards the end after the filtration comes into place. And so everything is chlorinated and ready for distribution. So that was one change that our infrastructure has already done when it comes to reducing disinfection byproducts exposure for our system at large. But there's other methods too. One is reducing water leakages to lessen the requirement of pumping and providing more flexibility for the operator. So less pumping from the tug fork, less water loss equals reducing disinfection byproducts. So again, the less that we can pump from the Tug Fork River, the more that we can depend on our Crum Reservoir, and the less water loss that we have can reduce that exposure. Another example that utility workers for our system can look into, and again, these are all things that we can utilize for our system at large, is increasing aeration and reduce holding time in tanks. Another is conducting target flushing for lines. That's one thing that I've been learning about our Martin County Water District is that they're doing a head count on hydrants and making sure there's hydrants for all the zones to be able to do more proper flushing for across our system. And that's something that is being worked on today. Steps, water utilities can take place to reduce the disinfection byproducts exposure. So all these different little things outside of this change of chlorination point, which has already happened, all these other different ideas can help our system at large reduce exposure around disinfection byproducts. So, next slide please. And so, next steps in this project. So, where are we going? What is next steps? Where are we at? So, when it comes to the Mountain Drinking Water Project and the community scientists, which is this vessel here, they're right now going to be working on a post-survey. At the beginning of this project, all the community scientists that worked with both Martin County and Letcher County did a pre-survey about their understandings around disinfection byproducts, what does it mean, where do you get your water knowledge and information. They're going to be taking a post-survey on this work and this experience and their time being a part of this project. And so that's one of the steps. Another step is deep listening sessions, interviews with some of the community scientists that participated in this work. That has already been started and has already been in the process of still keeping going in terms of interviewing more of the stakeholder consultation core members. And there's going to be coding and a report out about those findings later on. And then next is, when it comes to this project and work, I know we've talked a lot about water and we've touched a little bit about the air component of the disinfection byproducts, but throughout this study, we were able to use 4 homes out of our community scientists to be able to do air sampling in each of the homes. And we did 2 rounds of this air sampling. And then once we get the concrete results from that part of our project and study, we'll be able to come back and do another report out regarding how the air sampling results relate to the water sampling results, a little more deeper. And then lastly, but certainly not least, being able to take all of this information that we have gathered and learned throughout this whole project and being able to work with our water utility operators. I know Linda Ornsby has been working really closely with Alliance Water Resources on different computer modules and workshops that can be able to support the findings of this work to be able to think of the infrastructure on a whole another playing field of how we can reduce exposure through different models and systems and being able to apply it to action in the community and fixing the problems itself internally in the system. So, thank you. Just thank you to each and every one of you that has came out today. Didn't mean to get my flashlight on everybody. Just want to thank all the partners. If there's community scientists that worked with me and Nina McCoy here on this project, we just want to personally thank you, each and every one of you, because if it wasn't for the volunteers who took the time to support this project, we wouldn't have this information and data that we do today. I just want to thank the University of Kentucky, all of our partners here on our screen, for their efforts and support and collaboration through the whole step of the way, because this was not just a 5-year project, but counting the Martin County Water and Health Study, this has been over 7 years of work.
And you know, we still know that our water system needs a lot of help. We know that.
It's
Affordability is definitely a problem.
Yes.
And we want to know if y'all have anything that you can tell us to help the water system to do better. It's not a matter of, you know, I remember a long time ago somebody said, oh, well, maybe we should just do some water testing. Why doesn't the high school do some water testing? High school do water testing. I don't have the equipment to do water testing. So having the University of Kentucky and all the resources that they have has been amazing to be able to actually scientifically show what is and isn't in the water. So we really thank the University of Kentucky for that.
And again, this information will help engineers working for water utilities reduce formations of disinfection byproducts and the likelihood that these chemicals, can reduce carbon exposure to all. So, thank you all so much. Thank you for coming out. Any questions, please? Online or in person? We'll take them all. Yes, in the back.
Thank you all so much for this presentation and making it so clear. There was a slide where you had Martin County laid out with the different darkness levels of the dots depending on the concentration of the one that starts with a T. And you had a top of that slide. Thank you. How are you going, memory? Yeah. So it says that you didn't find any specific area, but maybe this is my untrained eye that's seeing well, it seems like there's a bunch of dark ones down there or over there. So I was just curious if you could speak to, is there a reason why that doesn't represent something that's regional within the county? Yeah.
Yeah, so, Wendell, who's the water engineer, and Emily, who's postdoc and analyzed the data, and I kind of sat down with the map What we're finding is it's not so simple as just like the amount of time that it takes the water to get there. It seems to be real specific to individual homes. So Madison did a really great job with the one that's sort of the darkest dot, where it's sort of at the dead end of the pipe. So the circulation isn't quite as good. There were other ones of the dark dots where it might be that they have a really long service line, which is the line that goes between like the water main and your house. And then there are other ones that were real close to a tank. So it seems to be like real specific to like the circumstances of an individual home. And it's not like, you know, the southern part of the county has higher than the northern part or anything like that, or even as simple as like how far they are from the water treatment plant. So Dr. Ormsby could add on, but, you know, he'll tell you that it's a pretty complex system. You know,
Our county has one of the most complex water systems in the state of Kentucky, which people don't appreciate. It's very, very complicated. We have like about 18 pump stations, approximately the same number of storage tanks. The system is divided in all different types of pressure zones because of the topography. So it's highly complicated. And so just looking at a map like that, like you said, you might think that there's a clustering of bad things here and the other places are not. It's actually a little more complicated than that. For example, Dr. Unrein mentioned storage tanks. If you happen to be living near a storage tank, sometimes during the day you may be getting water directly from the treatment plant. Other times of the day you may be getting water that's coming out of the storage tank. And so the water in the storage tanks typically will have a little higher concentrations of disinfectant byproducts because the water's been sitting there for a longer period of time, so the chlorine can continue to interact with those organics that might be in the water. So that's one example. You can potentially sample two homes right next to each other, and if one of them is getting water from the tank at the same time the other one's getting water from the plant. When you took the results, it would look radically different. You may think, what's going on here? They're next door neighbors, and this has got a much higher value than this. A lot of it has to do with timing when the samples are taken. So, did that answer your question?
Yeah.
But one of the things we do to try to capture that is we have some computer models that have been developed at the University of Kentucky, actually go back to the 70s, that can actually model all that in a computer and predict, like every few minutes, what the disinfectant byproducts or chlorine values are anywhere in the distribution system. And so we can use those to and use the data that's been collected to kind of check that against the models and develop or refine the models to use those for the operational evaluations. And that's one of the things that we've turned over to Alliance, is that now they have these models they can now run to see if I make a change in the system, how is that going to affect my water quality and things of that nature, and give them some guidance as opposed to just trying to guess.
And I guess just one more like very general question. So you were looking for very specifically disinfection byproducts in this case, and you mentioned, Nina, that study in 2020. Did that study satisfactorily rule out all other general water concerns, or was it specifically heavy metals, and are there other potential culprits that we haven't yet looked into?
Dr. Unrein.
Yeah, so we looked at metals and coliform bacteria in that study. You know, there are thousands of chemicals that could be in the water, but many of the ones that are commonly found in drinking water are regulated by the EPA. So those are things that are, you know, analyzed on a regular basis.
Okay.
You know, when they submit their, you know, regulatory compliance standards. Now, that being said, you know, as the science evolves, we find new chemicals that we're concerned about. So that doesn't mean in the future that scientists might not discover that a chemical that's out there that we didn't know commonly occurred in drinking water, and we may need new regulations. But Martin County is meeting, you know, the current regulations that are out there.
And when the EPA tests for that, are they testing at the water plant?
Well, it depends on the chemical.
Okay.
So With these disinfection byproducts, because they can form in the distribution network, they have to be sampled at different places.
Okay.
So other chemicals, they're mainly just coming from the raw water, and so they're gonna be pretty much the same concentration anywhere in the drinking water network, so they have certain monitoring locations. The ones that are different are lead and copper, and that's because the water chemistry can interact with the pipes in your home, so if you live in a really old home, the water can leach lead or copper out of the pipes in your actual home. So those samples are taken from the tap at homes.
No, great questions, thank you.
Yeah, those are really good questions.
Yes.
I guess I want to understand, like, I guess if you think from this presentation that if the answer is that, like, the byproducts, that they are within the regulation. And then I'm like, okay, so that seems to suggest that there isn't really a problem.
Well-
But then when I turn on the tap, it's a cloudy white water and it has a funny smell. So
Now,
why is that happening?
white, does it stay white, or does the?
If it sits for like 15 minutes, it will separate.
Okay, that is not settling, that's air bubbles.
Air bubbles in the lines.
Okay.
So that is one thing, okay? The other thing is, it smells like chlorine,
Yeah.
Go back to the,
because
one slide with the
it's
season.
chlorinated. And we're not saying problem solved. There are things above. We're not saying problem solved. We're saying we're similar to other areas. We are not the poster child for the worst water in the world. We're saying we're like everybody else and we want to fix it.
So, there's different kinds of effects that chemicals can cause. So, chemicals that can cause cancer, there's usually always a benefit of reducing the levels. So, there's some benefit to like exceeding the regulatory requirements. It costs money to do that, so it's a difficult choice that utilities face. But there's always benefit in lowering the levels even more than the regulatory limits if possible.
Just to add one thing, you mentioned about the chlorine and the smelling of chlorine. If you could go back to the map of the Warren County system, you got that here. One of the challenges that the utility faces is they have to chlorinate the water at the plant at a sufficient level, so when the water gets to the very end of the system, there's still a little bit of chlorine left over.
Yeah.
Because when you put chlorine in the water, as it's going through the pipes, it's slowly decaying because it's interacting. So one of the challenges is I've got to put enough chlorine at the treatment plant to make sure I've got an adequate amount of chlorine everywhere at the peripheries of the system. And that's also a regulated value. That's actually 0.2 milligrams per liter of chlorine. So the treatment plant, they also monitor for chlorine, and if they get chlorine gets low, and this typically will happen more in the summertime, they may increase the chlorine levels a little bit at the plant to make sure they're still keeping chlorine out in the system. The delicate balance, though, that you then have is if you increase your chlorine too much, you're going to start forming more disinfectant byproducts. So it's a real tricky balancing act to make sure that you've got your chlorine in a level so that you're getting disinfection, but not too high that you're starting to cause a lot more disinfectant. So that's one of the benefits of having a model like we talked about, that they can kind of do simulations of the model to see, hey, won't you be setting these values at to keep this balance? So the operators have a tough job in doing that, especially with a system like Martin County, because it's so complicated and complex. You've got all these storage tanks that are affecting things and the different pressure zones and so on. So, but over the last year, we have seen some improvement in the chlorine maintenance, and also DVPs have actually gone down a little bit from some of our observations in the distribution system. So they've been monitoring at homes. We have some other teams that are actually going throughout the distribution system and sampling from fire hydrants to see what the concentrations are actually in the pipes themselves and trying to make sure that everything's in compliance there, so that kind of explains it.
Yeah. Any questions online from anyone, Roger, from Mount Simpson?
No.
Any more questions from the audience or any comments? Anything in general?
We have one more.
Yes, of course. No, please.
Okay, so you had the slide where you mentioned like common ways we are exposed to these things. So I'm using bleach to clean my bathroom or kitchen or something. So I guess I'm trying to understand like the quantities here. So if I use bleach to clean my bathroom once a month and my kitchen once a month, and I go swimming in the community pool that's chlorinated once every week in the summer. I mean, are the amount that I'm gonna drink comparable, or am I already being exposed to so much that it's, those seem like pretty intense
Yeah,
exposures.
so
Yeah.
when they make the drinking water regulations, they consider other sources of exposure and then what the drinking water adds to that. So it's sort of, you know, they do take that into account. But of course, everyone is a little bit different in what they do, so.
I might also add, in case you can reiterate this, those numbers, those standards like 0.08, they do risk analyses to come up with those numbers. And typically, those numbers are based on a lifetime exposure, and they have a certain assumption that you're being exposed for 70 years on a daily basis at a certain concentration. So there's some conservative nature built into those numbers. So it's not meant to alarm people, but they're very conservative.
Yeah, and there are safety factors built into the regulations as well. So like you wouldn't build a bridge to hold exactly the amount of weight that you expect to cross it. It's built stronger than that. So there's a similar principle in the drinking water regulations. But on the other hand, you know, as science evolves, we learn more, and sometimes the regulations have to be decreased. So.
Awesome. Any other questions, comments from the audience?
I appreciate it.
Yes.
Appreciate you coming. I feel reassured about the water compared to what I did before I came here, so we want to tell you that.
Thank you so much. Thank you for coming.
Can I say something?
Yes, Jason, go
Yeah,
ahead.
I just wanted to say, on behalf of the University of Kentucky, Nina that came to us and said, this is a problem that our community is facing. And we weren't even studying disinfection byproducts before this, so she's been a teacher to me to show me this is what the important water quality issues are in our community. And so this has been kind of a two-way thing where, you know, I really appreciate, you know, this whole journey that we've been through together, and thank you so much.
Kind of a bottom line question to ask you. As a group, this group probably knows more about the performance and content of drinking water in the county than anybody ever has. And I've lived here off and on pretty much all my life. And when I was growing up, everybody had well water, and we didn't have any that I know of, anybody in the county ever get cancer, or for that matter, bladder cancer. And I don't know whether their antiquated water plant was to blame or not, but I know that when I got bladder cancer in 2010, I did some, I called the CDC and had, got some numbers from them, and at that time in 2010, they had the 4 highest ranked bladder cancer counties in the state, and Martin County was number 1. And that was in 2010. So if we made the improvements that you all indicate, I'm very grateful for it, because in addition to losing a kidney, I had 3 or 4 bladder tumors removed. But I guess where I was going with this, since you're acquainted with our water plant and its operation of the district. Do you think the water in this county, as it comes from a faucet, is safe to drink?
Yeah, I mean, what I can say is that it meets, right now they're meeting all of the EPA regulations. You know, it's not in violation. It's not so much as like safe or not safe, it's safer. We're always trying to work as hard as we can to make drinking water safer by reducing contaminant levels. And I think Martin County has done a really good job, the water district here, in reducing the DVP levels, you know, since those times when the notices were coming out that they were in violation of the Safe Drinking Water Act. And you know, as you can see, that's a widespread problem across the state and the nation that we're dealing with, so.
And just know that the University of Kentucky is not going anywhere. I've already told Jason and Linda and Anna and the rest of the crew, once you're in Martin County, you're stuck in Martin County. So there's gonna be more work that's to come with the soil
Again,
and water.
we want to get better, we want to exceed.
We want to set the standard.
Really meet the standard all the time.
Yes, yes, Vernon, you had to.
You answered my question, I'm gonna ask, are they done with us now, or are they gonna?
No, I'm glad I answered it before you. Yes, they're not going anywhere. I know we're always.
Now, Madison said that, but we didn't hear that from them. did we?
Well, he's told me, say it out loud, Linda.
Well, we actually have another project we're working on. I can just give you a heads up on that. There's actually a flyer over on the table, but we're in the process of developing a online video game that you can play that models the water system. And you can basically take on the role of an operator and use the game to operate the system to try to improve the water. So we hope to release that in January. Nothing else I may be bring for your kids or your grandkids to get a hold of. And that's based on a lot of the studies that we've done and the model that we've developed to simulate the way the water system works. So that's one thing we're continuing to work on. Jason may have some other.
Yeah, I mean, we're within the Kentucky Water Research Institute, we're in constant contact with like the Kentucky Rural Water Association, Division of Water, water utilities. I mean, we're here to help. You know, we're our public land grant university here in Kentucky, and we're here to serve and to help, you know, our citizens with whatever problems that they have. We're not going anywhere.
I know I kind of passed out some forms as we're doing the Q&As. I just wanted to make sure everyone got some documents. And for the people that are live streaming at home, if you're interested in any of these types of documents that we have, like tips and reviews of exposure, the past Martin County Water and Health Study results, please don't hesitate to come to the Martin County Senior Citizen Center, also known as where my office is for the Life and Knowledge is located. And I would love to share this information with each and every one of you. And also for the folks in the room, we have this lovely little side table. It has some paperwork and some other documentation, and also just a kind of like little hands-on thing that you can see that our community scientists worked with for years in terms of like how we gathered water samples. So if you're interested to take a look at how that process went, or just to learn more about the project itself, feel free to stay and ask more questions. But thank you all so much. Any other questions or comments from the audience? If not, thank you all so much. Thank you everyone online. We appreciate your support. Tune in next time. We are going to be at the Warfield Community Center tomorrow night, 5:30, to present the same information yet again in the other side of the hill. And we'll also have some of our UK staff here to support with any questions or comments that the community has. Thank you all. Good night.